On this episode of the podcast, I have with me Jordan Kaye. He is head of technology at Belvedere Trading. We're going to be talking about tech debt and the fact that not everything is technical debt. We're going to define it, understand Jordan's perspective. He mentioned something about quality versus velocity and how high quality makes you faster. And actually, high quality is a neighbor of velocity. We're going to dig into that. And we're going to talk about decisions made versus hindsight, because obviously it's very easy to call something technical debt when it's not working your way. Jordan, thanks for being on the show.
Yeah, thanks a lot, Amir. Happy to be here.
Absolutely. All right. Before we start, Belvedere Trading, what do you guys do over there?
We are a trading firm. We're a proprietary options market maker. So what that means is we provide liquidity to markets, and other market participants get to choose whether they trade with us.
Awesome. I'm sure there's a lot of development that goes in there to make that work, and we're going to talk about the tech debt side of the house. I like this topic. Actually, it's been coming up more and more talking about tech debt in the sense of why are we referencing it so much? It's actually become a curiosity to me to understand from CTOs, technology leaders, as to why this is constantly a part of discussion. And before we start, because I've also realized that technical debt does have a nuance that there is various meanings of how people interpret it. And I guess from your perspective, it'd be great to start to understand when we talk about technical debt, what does it mean to you?
So I think it's a super important thing to talk about. One of the big issues with technical debt, in my view, is that people will spend hours and days and weeks talking about it without ever confirming that they actually are talking about the same thing. So I like to call it like the tech debt boogeyman, where, everyone's just complaining about it. Tech debt. But no one's ever said what actually is debt. So I think people have many different definitions. Probably the worst one, in my opinion, is anything that I don't like in the system. Maybe, yeah, you might see that a lot from some engineers. One that's maybe a little bit better is anything that gets in the way of us moving faster right now. Personally, I like to use an even more specific definition, which implies that tech debt need to be decisions that you're making consciously. Much in the same way as financial debt, you can't get into financial debt by accident, right? No, you don't just show up one day and have credit card debt. You need to decide to take that on. And that, to me, is a really important element of considering what is and is not technical debt, is that you need to say consciously, all right, we're taking this on, that this is debt that we're willing to incur.
I actually love that. I love the fact that you said tech decisions need to be a conscious decision. Tech debt, normally when I've heard about it, I've not heard that definition, so I think that's interesting, and I'd like to maybe explore that a little bit more, because as I've seen tech debt being defined as, I can't do something because this has happened, a pre-made decision, pre-made path, and now I'm responsible. I guess when you're looking at tech debt generally, and you're looking at your definition, and you come into an organization or you're dealing with new hires, how do you help them understand that? Because I think a lot of people who come from other environments and have dealt with the notion of tech debt, sometimes it's the blocker. It's a, hey, this is out of my hands, and this is why it's going to take us a lot of time, or it's going to cost us a lot. It's that 800-pound gorilla in the room that could really morph into anything. How do you help someone understand that that might not be how you define it at your company, your engineering org?
Yeah, that's a great question. And I'll readily admit as well that the definition is less useful if you're not able to really to apply it, not quite from day one, but early on. The further you get into a project without defining it this way, without quantifying the debt, the more difficult it is to use the definition that I like. The flip side is that's why I like this definition so much, is because to me, the step zero to resolving tech debt is to be able to quantify it. And to be able to quantify it, you need to be able to make a conscious decision. And so the way that we explain it, it's actually really easy, because when you have the debt quantified, we actually have a graph where you can see the amount of debt that we have accrued over time and when we've decided to pay it down. We have a ceiling, we have a floor. So we have actual numbers that show us, like, when we're reaching a certain level of debt, we know from past experience that we need to start paying it down, or else there's a good chance that it's really going to start getting in our way. And so someone joining the team and being able to literally pull up an issue board and say, what's all the debt that we perceive to have in our system? That clicks immediately. It's kind of a freeing thing even to be able to look and see like, oh, we're not on C++23 quite yet. Sure, that's debt. We decided not to do that. But someone could also pick that up. We also have an allocation of time that we put towards things like debt and Slack work. So it's really all built in there together. But the reason I like the definition so much is it enables the quantification of debt, which I think is the most important aspect.
I actually think that's really great that there is actually a visual, and anybody at any time can go take a look and see where they're at. When I hear this, and your definition's a little bit different than what I've heard, so I'm really interested. But when you kind of think about the definition and you start thinking about these decisions that are being made in real time, are there other? And I'm trying to think. Maybe I'm wrong, and if you don't know, it's okay. But are there other departments in companies that go, we make these decisions, and we are going to incur some form of debt, and it's going to impact us at some undefined amount and undefined period of time down the road? Because I don't know if accounting finance has that, or the marketing team has that, or the sales team have to deal with that. And the reason I'm asking is because it's interesting to me, because it seems like a lot of pressure on a technologist to come in, make a decision, and know that at some point down the future, because technology rules will change, your decisions are going to be examined by someone else, if not you, or maybe yourself, down the road, and there will be hindsight views of that. I mean, it seems like, gosh darn, it's not the easiest position to be in, but I mean, it's the job.
Yeah, and I think it really, if you look back so Ward Cunningham is the one who originally coined the term tech debt, right? And if you look, he actually has an explanation of what he meant by the metaphor. And in many ways, it mirrors what you just said, which is taking on debt isn't saying we're going to go write bad code or do things incorrectly. Like you should never write bad code. If you know you're doing something wrong, don't do that. Just never ever do that. Instead, I acknowledge that I have a possibly flawed conceptual model of what this is right now, but I'm going to move forward with it anyway, because that's what I need to do to actually make progress right now. And so what you're doing, all you're really doing is making explicit decisions that we're actually making every day, which is, I'm going to trade off a little bit of future velocity in exchange for being able to do something right now. And so another way that I like to say that is, we all have to be grown-ups. Like, whether or not we write this down and admit to doing it, we're all doing this every single day. So why don't we write it down? Because it only helps us to get better if we can go back and look at those decisions and see, hey, I decided to go with this data model. It might have XYZ problem. That's the other thing about tech debt. Some debt never actually materializes. I call it materializing. There's some debt that you can just close. It's in there for 3 years. It's totally fine. No problem. Just close it. And so it's more like this might impact velocity down the line, or this might need to be changed, but I don't know. And that's what I'm saying. So yeah, I think it applies definitely beyond technologists for sure. Maybe it's not tech debt, maybe it's like conceptual debt or model debt or whatever you want to call it. But I think roles beyond technologists probably have to deal with this too.
Yeah, it's you make some interesting, these are interesting observations, because I was thinking, I don't know accounting that well, but I'm going to pretend I do. So I was just going to put my CPA financial hat on. I'm going to assume if I am, a CPA and I am managing last year or the year before's, books, there's certain tax laws for that year I abide by. And then the next year starts, I am current on the tax laws. I don't go back and go, 8 years ago, we need to make adjustments because the tax laws changed today. It's only to look forward. I think with technologists, and you mentioned, I'm curious about your viewpoint is this, that decisions are being made not only with the understanding of the problem set, but also the current tech available. So it's twofold, because we're also looking back going, well, as tech is maturing, improving, evolving, we can look back and be critical of not only the decision, the business justificated the reason, but also as the tech still support what we did. There's so many different factors. And I think that's an interesting pressure, because an engineer who's, let's say, predisposed to liking elegant technology solutions might view a piece of code as tech debt because it's not written in a more modern or elegant way or less lines of code or whatever, versus, hey, it's still working. It's a unique situation. I mean, some of it is unique to engineering because the ship is still moving on. It's not like at a point in time we can kind of cut and say, look forward. So when you think about the fact that technology is shifting, and you have to look at tech debt, at what point do you go, well, this code, you said 3 years, this code's been working for 2 years, no matter what, as long as there's not a dependency, we don't touch it.
Yeah. And, I think that's where it's another reason that I like that pedantic definition that requires the intention, because it's really easy to come into something that's working well, not causing problems. That's also important, like not incurring a bunch of toil, to come into a system, maybe not fully understand it, maybe it's not aligned with your preferences, and just say like, well, this isn't good, it's tech debt. But where's the impact? And that's always the question I'm coming back to is, as technologists, as software engineers, our job, code is like the output that we create, but our job isn't to write code. Our job is to impact the business. And so if you have a system that's running, it's stable, it's working, it doesn't require a ton of maintenance or changes, like, sure, you could come through and rewrite it from Vue to React, but what does that achieve? And so we could make up different situations where, well, we're expecting to add a huge feature in 6 months and we think it'll be easier. But again, that's not cleaning up debt. That's just a project that you need to do to enable something you want to do later on. And so I do think there is a unique element to engineering for sure, because these systems are living, they're not frozen, they're being like used every day. And also the world changes out from under you. If you're in an operating system version that's being end of life, you have to address that. But then again, do you want to be doing operating system upgrades in like random engineers 20% tech debt time? No, that should be, in my opinion, that should be an initiative that's like driven across an organization, an actual project that real time is dedicated to, and not something that's just like, oh yeah, the engineers have to deal with that. So it requires a level of what we call like organizational buy-in, or maybe maturity is the word. I don't know what the right word is exactly, but that's another important part of that distinction, is not just foisting everything on the engineers and saying like, well, these are your systems, deal with it, but saying like, here's your discretionary time to fix the things that are important to you, and here are the things we need to do as a business.
I think there's probably a billion scenarios that exist, and these are all tough decisions. I did have another CTO, and I was joking. I was kind of referencing it would be great if, as engineers could code, they could record their thoughts in voice and attach it to whatever they're coding, because somebody could actually go back and listen to it and be like, oh, the comment doesn't make sense, but I hear what you're trying to do. And it's interesting because a lot of what I hear about, and even if it's conscious decisions, this is one of those cases where somebody has to go back and decode something. I have a hard time replicating the same dish that I make at home cooking a dinner. Like, I'm like, my wife's like, can you make that again? I go, if I happen to sprinkle the same amount of seasoning by accident, absolutely, but it'll be kind of ish like it. And I think when you're saying conscious decision, I'm kind of looking at that going, you have to have that business understanding. You have to understand the technology, the decisions made, the technology trade-offs. And on top of it, your team has to deliver at a certain velocity to actually reach all the objectives. We can't sit and wait for these perfect solutions. Decisions have to be made. There's timelines and deadlines. When you look at the conscious decision and you look at the factor of time, obviously the discussion of quality and velocity here comes into play, because spending more time doesn't mean more quality, and spending less time doesn't always lead to a really good quality. How do you balance that conscious decision and going, this is the optimal sweet spot between making sure we're doing things as well as we can versus incurring not unconscious decision debt because somebody isn't doing something well?
Yeah, a great question, and I think probably one of the key tricks to successful engineering. As a quantitatively minded person, we're always trying to stay on the Pareto frontier, right there, that 80-20 rule, which is sort of our guiding light for the balance. If you can get 80% of the benefit with 20% of the effort, and that last 20% of the benefit is going to take the remaining 80% of the time, try to find that line. Now, it's much easier to say that than to do it. And so part of that, I think, really does come down. You said like the business understanding. I think that's a super important element. And I also think that business understanding cascading to ownership and autonomy for each team. So not only do you need like your stakeholders and maybe your leads, directors, whoever do have business understanding, but you want every single person in your organization to have that level of understanding to the point where teams are able to fully own what they do. That's really hard to achieve. But when you can achieve that, now instead of having 3 or 4 or 5 people who can make these decisions on where that Pareto frontier is, you have maybe 50 or 60. And those are the people in the weeds who know the most about what they're doing, know the most about the systems. So, there's always going to be mistakes. And even with the, conscious quantification of debt, you're going to miss things. And so the point is never perfection. It's more like a shared understanding or what the goal is. And if you miss something and forget to put it in 1 week and you do it 2 weeks later, that's fine. It's not a problem.
I guess in the sense of, you made a comment and I wanted to touch on it. You'd said the high quality is enabler of velocity. And obviously I can understand that from the perspective of, well, if you have less things that go wrong, either initially or later down the road with tech debt, when you look at that statement and you want to make sure, obviously, you said the 80-20, obviously making sure, we're executing at a decent pace. Is there a case where you can actually go too slow and hoping to reduce issues, reduce, problems down the road? Is there a time period in which it's like, listen, this is as good as it gets, 80-20. If we wait for any longer, we're going to run into problem. But we do need that velocity to not be hindered by unnecessary issues and tickets.
Yeah, and I actually have a post that I wrote called "Flexible Systems," a really short, just kind of reflection. But the key point of that post is the way that I think about this is that the number one most important property of a system, I believe, is flexibility. There's a great book about that also called Slack that talks about optimizing an organization for agility, flexibility. And I think that's really the key is like, if you think about slowing down and you're like, we want no bugs ever, so we're going to do a monthly release cycle. You may or may not achieve that goal of no bugs ever. You probably won't. There's a limit to what you're going to be able to test, but deploying once a month massively limits your ability to be flexible. And, this is where you see Agile and CI/CD, and, you hear about organizations deploying 400 times a day in production. And that's why they do that. They're not thinking we want to move as quickly as we can so that we can break things. I know move fast and break things is a thing, but that's not the goal. It's so that if something does break or you do have a problem, it's not actually a problem because you just deploy the next thing. So you're optimized for flexibility over correctness. So that doesn't mean you never think about being correct. You want your conceptual foundations. That's where you want to spend your time. Your backbones, your APIs, like the interactions between your systems. But then inside any given box, you can really open up those bounds of autonomy to each team and say, hey, just iterate. And so there's all levels of what that'll mean, and people have compliance regulations and whatever else. But ultimately, I do think quality is this weird dichotomous thing where you imagine, well, in order to have high quality, we have to go slow. And I think I said it to you in our intro chat, but it can take some time to get to a point of high quality. But once you get there, you really enable yourself to move quickly because there aren't all of these little things getting in the way. Your inner development loop is fast. You have a great high quality test suite. Your documentation is really good. You have great development environments. You have awesome static analysis. These are all things that allow your developers to just iterate and move. And it just removes all these barriers. So certainly, there's balance to everything, but if your answer to how do we get more quality is let's really slow down, you're going to want to make sure that when you're slowing down, you're spending time on force multipliers, not on slow down on every single feature you do.
I think that's, I think there's an art in there, and I think it's not as easy as it sounds, but as I'm listening to it, I'm like, okay, well now it does make sense. And I think, technologists, are very good problem solvers, and they're always looking to solve problems. And it's interesting, as I talk to more people, I'm realizing a couple things, that sometimes they can end up solving the wrong problems because there's an interest to solve problems, and you could accidentally go, oh, this is a problem that needs to be solved. And in the case of tech debt being conscious or unconscious, velocity, quality, you could decide to try to optimize some of the wrong things, which I think a good engineering leader will step in and say no. But I think it's an ebb and flow. And one thing that's coming up that I was going to ask your opinion about, and I think is fascinating because I had never really thought about it, was technologists are really good at listening to a problem, and they start solving that problem. They're modeling in their head, they're taking the pieces, they're putting the Lego pieces together, and they're doing it in real time. And sometimes you wonder whether it's a bit of the cart before the horse, and would it be better served saying, hey, don't start thinking about how you could technically solve this problem, because you might actually design something that necessarily doesn't need to be, solved, doesn't need to be picked up on. Again, it could be a case where, there's a more business friendly solution that doesn't need as much technical debt. Is there a notion in your world where, when you're trying to take that business understanding in, and I guess this kind of goes back to something you mentioned about, trying to serve the business, and make sure that that's firmly grasped before you start modeling? Because I think there's a tendency, as you get more senior in technology, to kind of flip that switch on and start doing that. Does that help us understand the problem better? Is that a common thing, or is that just maybe a couple people have mentioned it and I've found it interesting?
No, I think it's common, and I think it can help. So, everything, all of these things always have their shoulds and shouldn'ts, and when they apply and when they don't. But, highest level, I do think that the idea of not solving problems too early is really important. And part of the reason is, in general, again, nothing's completely true, but in general, the rate of knowledge work is mostly fixed. You're not going to be able to get that much more work out of a given person. You either need to increase the hours, or your other lever to change what gets done is to change the actual work that's done. And so what that means is you need to be really judicious about picking your scope. Not only picking your scope, but picking which projects to work on. And I think for a lot of organizations, that's one of the really big challenges. Is, you could execute a project flawlessly, perfectly in every single way. And if it was the wrong project to do, you might get zero or negative value from it. And so that, for me, is the key thing, is when you're thinking about when should I solve that problem, you should try to solve that problem just before. I always call it just-in-time scoping. So that's what we call it, is not saying don't think about things or be haphazard, but the time that you should fully scope a project and start thinking about solving it, in my opinion, is a month-ish before you're going to work on it. And that's assuming that your projects are small and tightly scoped, 3 to 4 weeks long, maybe. So this isn't some, 5-year long mega thing that you should just think about, a month before you do it. So I'm assuming a level of agility or high velocity or whatever. But that personally, that's how I always deal with it. Because what a failure mode that I've seen in the past is, we're going to just go ahead and scope every project for the year at the beginning of the year. And what you find is like the projects in January are really well scoped, but then February it's a little rocky. And then by the time you get to March, it's like, well, things have changed a lot. We kind of have to rescope this. And the ones in November, like, forget it. Those projects probably are never even going to be done if we're being honest. And so that ends up being just a ton of wasted work that you really didn't have to do. And so, places with like incredible project managers or that are on, really long contracts, these super long projects, I'm sure the situation's different. But if you're in like a highly dynamic type of environment, that would be my suggestion, I think.
I mean, great insights. I know you got to get back to it. I'll end the conversation there because you've provided. I love the examples. I love the definitions. I love kind of the thought process of how you view tech debt and conscious decisions behind them. I'm sure we haven't exhausted the topic, and we probably spurred some thoughts for others that they might want to further. Is there a good way touching base with you if someone has a question based on something you've mentioned on the episode?
Yeah, my LinkedIn. I think there'll be a link in the podcast to that, and then I have a personal website, which is jordankaye.dev, just my full name spelled out .dev, where I try to write like once a month about leadership or just interesting tech stuff that is on my mind. So those are probably the two good spots.
Well, we'll make sure to include those in the show notes. Again, thanks for being on. And that is the end of the episode. We'll be back on different guests, different topic. Until then, two things. One, please share this episode with others because I think it was a great discussion. Jordan actually defined tech debt in a way I hadn't really discussed before about it being a conscious decision. I mean, we talked about velocity, quality. We talked about how you enable better velocity through this and looking at those decisions in hindsight, and a lot of insights. And please share this with somebody else who's in the engineering field that could benefit from this. Also, like, subscribe, comment. Let me know how the podcast is going for you. Until next time, thank you and goodbye.